students, today's topic is completely randomized design. So it is a design in the topic called design of experiments. Okay, it is very much important for semester 6. The students who are studying semester 6 related to statistics, the paper name is Applied Statistics 2. Okay, so let's see. Completely randomized design, in short form it is called as a C.R.D. Okay, so we are having in design of experiments, we are having three methods, that is random block design, and the second one is C.R.D. completely randomized design, and the third one is Latin square design. So these three are the designs we are having in design of experiments topic. So now we are going to discuss what C.R.D. Okay, so C.R.D. in the sense what? Completely randomized design. See here, a completely randomized design where all experimental units are randomly assigned to treatments. So what is experimental design? What are treatments in the sense? I'll give one example for you. So see here, there is a hospital. So in hospital, who will be? Mostly patients, okay, and doctor. Okay, so here the patients are called as experimental units. Okay, here the patients are called as experimental units, and doctor is called as a treatment. That means he may have some treatments. Okay, treatment. Okay, for example, three patients came with fever, and the doctor is willing to give treatments for those patients. So for one patient he may give syrup, for other patient he may give medicine, and the third person he may give some injection like that. That means what? Without having the knowledge of the persons, he randomly pick and he give the treatments. That is called as what? Completely randomized design. Okay na? So randomly designed to treatments. Okay, this design ensures that every experimental unit has an equal chance of receiving any treatment. As I told you that three patients may receive any treatment. Okay, there are equal chances. There is no particular that the first person should receive the medicine, the second person should receive the syrup, the third person should receive the injection. That is no particular, there is no pattern. Okay, randomly he selects the patient and he give the treatment. So that is called as every experimental unit has an equal chance of receiving any treatment. Okay, which helps in reducing bias. Bias in the sense what? There is no partiality, no favoritism. Okay na? So everybody are equal to the doctor, and ensuring the validity of the experiment. So it shows that the experiment is what we say, validity in the sense accuracy. Okay, we can say it as a accuracy. See here one example we'll see. Suppose you are testing the effect of three different fertilizers. We are having three fertilizers, so we want to test which one works more efficient. Okay, so on plant growth, you have 30 plants. So we are having 30 plants. The 30 plants are called as experimental. Each plant is called as experimental units, and A, B, C here are called as treatments. Okay, in a C.R.D. you would randomly assign each plant to one of the three fertilizer treatments. So what? Here 30 plants, one plant randomly we pick and we give one treatment, and again we pick another one and we give treatment. So that means without having any knowledge about the fertilizer and the plant, which one we are going to select, we don't have any knowledge in previous. That is called as what? Randomly assigned. Okay, yeah, that means each plant, each treatment receives how many experimental units? 10 experimental units, isn't it? Yeah. Now advantages. We'll see about the advantages. So advantages, the first one is its simplicity. Why it is called as simplicity? In the sense easy to understand and implement. Why? Because there is no particular pattern we have to follow. We can randomly pick the experimental units and we can give the treatments like that. So that means what? Here we are having easy to understand and implement. Okay, next, flexibility. Can be used for any number of treatments and replicates. That means what? We can use one treatment how many times we want, we can use to the experimental units, and also we can repeat number of times in order to get the final result. We can repeat the treatment. That is called as flexibility. Okay, yeah. Next, reduce bias. Yes, now here in previously we learned that it is reducing bias. Bias in the sense what, there is no favoritism, there is no partiality like that. So randomization helps in balancing the effect of conflicting variables. As no randomization in the sense what, we don't know whom we are going to select like that. So that's why it reduces bias. Okay. So now disadvantages. So disadvantages means homogeneity requirement. Homogeneity requirement in the sense what? No. So homogeneous means we should have equal number of experimental units. Okay. Yeah. And everyone should receive equal number of treatments. See here in the above example, A, B, C, here 3 treatments we are having. Sorry, 3 experimental unit. Yeah, sorry, ABC are the treatments and 30 plants are experimental. That means each plant receives, here the treatment, each treatment receives 10 plants we discussed. That means what, here homogeneity is maintained. Okay, so that, so here compulsory we have to maintain the homogeneity. If the homogeneity is not there, C.R.D is not applicable. Okay, yeah, next is sensitive to variability. So sensitive to variability in the sense what, if experimental units are not homogeneous, this design must be less efficient, as we told in this point only. So compulsory we have to maintain homogeneity. Homogeneity in the sense what, for example, if we take 25 plants, there won't be equal share in the treatments, isn't it? So that means there should be mostly homogeneous variables. So that is called as sensitivity to variability. Okay, so if you want to learn about the layout of C.R.D, so you have to stay tuned with my videos. So please subscribe to my channel for latest videos. And also if you like, please click on the like symbol, comment which topic you want, and also share with your friends. Thank you. Have a nice day. Bye. Take care.